My name is Matthew Yahov, and today we will talk about Verse Analytics internal structure. This video is intended for those customers who plan to deploy Versa Analytics in their own environment, meaning that you don't want to use Versa Managed Services, or you have big enough structure to have your own head end, or maybe because of the security policies of your organization, you want to keep all the analytics data in your own environment. First, let's review the standard process of data flowing between the SD-WAN devices, firewalls, and the analytics nodes. All the devices, doesn't matter whether it is SD-WAN device, if it's a router, switch, firewall, and so on, they will send the data in the IPFix format, meaning all the logs, all the statistics to the controllers. And controllers, using load balancer embedded in them, will load balance those connections to the Versa Analytics nodes. Also, controller will act as the component which does failover in case if any of the analytics nodes becomes unavailable. Now let's review in a little more details internal structure of the Versa Analytics. Main components of the Versa Analytics are the database, web server, log collector, and driver. Database, usually there are two types of the database, one of them for the statistics and second for the log records. Web server is based on the Apache Tomcat. That's basically your web interface which reads from the database and combines data in the proper graphs or shows it on your screen. Then we have component which is called log collector, which receives all the logs from the controller, which load balances them from all the devices in your network. And we have a driver. Driver is the component responsible for reading archives which are created by the log collector and putting them in the database. Now let's review in a little more details about the database types and the analytics roles. So each of the analytics nodes which you deploy, or each of the analytics servers which you deploy, can have one of three roles. It can be either analytics role, search role, or log forwarder. What is the difference between them? Analytics node contains historical data such as bandwidth, SLA measurements, and other graphs. Here's an example of the data which is going to be stored on the analytics node and therefore will be read from it after. On the search node, we usually store the log files, log records like who accessed what at what time, from where, and to where. Here's an example of what is going to be stored in the search role. And the log forwarder, as the third type of the node, doesn't have any data. Log forwarder will only forward logs from the controller to the actual databases. Usually log forwarder only installed when you have a big enough deployment consisting of thousands of SD-WAN branches. In this case, for scalability, it's just required in your network to load balance TCP connections. Now, let's see which components are installed in each of the nodes, node types. On the analytics roles, we'll have a database with the statistics. We will have web server, log collector, and driver. On the search node, we will have another type of database. So we will also have the same web server, log collector, and driver, but the database type is going to be slightly different. All the database types which are deployed and used in the Versa Analytics are based on the Camtasia. It's just that internal structure is slightly different. And log forwarder doesn't have any database, it doesn't have any web server, it only contains log collector which receives connections in the IPFix format, and the driver who pushes them later to one of the two nodes in the system. Let's review in a little more details the processes, how it's actually happening. Here's the Versa controller and two analytics nodes. One of them is the type analytics role and the second is the search role. So you can see that the databases are different on both of them. When the controller receives some logs, let's say that we received some log with the statistical data. So this log is going to be forwarded to one of the analytics nodes. So let's say that it got to the log collector on the analytics role node, and then the driver. So first of all, log collector will store this in the archive, so the local archive which you later can review, copy somewhere else, or recover if there is any problems with any of the nodes. Driver periodically reads this data from the archive and pushes it to the proper database. In this case, because it sees that it's a statistical data, it will push the information right into the database which contains statistics. Let's take another example. Let's say that in this case, controller received log data, but it sent it to the same log collector. In this case, when driver will read this information, it will know that it needs to push the data in the database with the logs. So even though data was received on the node which contains only database with statistics, driver component knows where to send it because it has the record of what type of data needs to be put on which of the databases in the system. So this is a little about internal structure. Now, scalability in case if we have a big deployment. So in case if you have like a really big deployment, you will probably have a log collector as well in your system. Log collector installed between your controller and between your analytics nodes. Actually, sometimes log collectors also installed as the redundant nodes where they only store archives in case if the main nodes are unavailable. So in this case, when the log of some type is coming to the controller, and let's say that is being sent to the log collector on the log forwarder, it's going to be read by the driver, and driver will directly put it in the proper database. So I hope this clears a little how the internal structure works. Now let's review in a little more details how data is being read by the director when you log into the management interface. So here you can see a couple of networks. So we have a couple of analytics nodes, one of them of type search, second of type analytics. We have the controller with load balancer ADC, or application delivery controller as it's also called. So we have control network and we have management network. Control network, that's usually the network which connects director through the controllers to the rest of the SD-WAN world. And we have management network where you have access through the GUI to your director. In many cases, you might not even have connection through the Ethernet 0 to the search analytics nodes from the director, or maybe you will not expose them to the internet. So the only component which needs to be exposed is the director to the rest of the world. And when you log into the director and you want to read some information from the analytics nodes, first of all, let's take a step back. So first, we have the IPFix flows, which are coming from the load balancer to the analytics nodes. We have internal network between analytics nodes, which is used by the driver to synchronize data between the nodes. Or if we have nodes of the same time, for example, you have two analytics nodes or two search nodes, the data can be replicated so that you have redundancy between your nodes. So now, let's assume that you logged into the Versa Director GUI interface and you went to the analytics page. So you sent a request to the analytics, and the way how the information is being delivered is that the information is actually being pulled from the web interface. So basically you're proxying web interface on one of the nodes, and if data is located on the analytics node, the Tomcat server pulls it from this node, and if it's located on the local server, it just pulls it from the local node. Now let's talk a little about redundancy. Redundancy in the system. Here is a recommended production deployment where you have two data centers with the disaster recovery configuration. The recommended deployment is that you have one controller in each of the data center, at least one controller for redundancy. You have the main WAN cluster consisting of 4 nodes, meaning that you have 2 analytics nodes and 2 search nodes. Why do we need 4 nodes? Is because each of the nodes will be replicating with each other. So analytics will be storing the same information, and in case if one of them fails, second still have the same data. And the search will also be replicated between each other. Also, it improves the speed with which data is being processed, because we can use in parallel multiple nodes of the same time to retrieve different data of the same type. And in the redundant data center, it is recommended to deploy only log collectors, mainly because the request from the director usually goes to the main van cluster, and in the redundant data center, we usually don't ever pull the data from there. We just store information in the log collectors, and when the main nodes become available, we push the data into the main nodes. How redundancy works? In the regular operations, all the IPFix flows, which come from controller 1 and controller 2, will be sent to the main analytics cluster or Versa analytics node cluster. In case if any of the nodes fails, the controllers will just fail over those connections to the remaining nodes of the Versa analytics. If another node fails, again, it's going to be failed over to another node. If one more node fails, again, all the connections are going to be going only to one of these nodes, and the driver component will be waiting when the search type node will become available so it can push the data from the archive to it. Only in case if all the node fails, controllers will redirect all the IPFix flows to the redundant analytics cluster. So, and their data is going to be stored until the main Versa Analytics node will become available, and then driver will just push the data which was collected during the time of the blackout from the archive to the main database in the main analytics cluster. I hope this was informative for you, and thank you for watching.